Hello, this is Mike going through week four computer operating systems for the 1906 section. I'm just going to click through these pretty quick here. So I'll go through package management. First thing here, I think we'll go through package management. There we go. All right, package management. Nice little thing there. Package management is what to use on Linux boxes to install different packages. When you install a minimum version, when you install the UI version, there's typically a full version, will have most of the stuff you'll need for a desktop. However, if you do a server version, it'll only have what it needs to do a server, and there'll be lots of other things that you may or may not want to do. And the way you get that additional software on is to install packages. In, so here we'll look at what a package is. Well, package is just a set of software. It's a set of parts of the software, all the dependencies on there. So say you need to put a SQL database on there or some kind of database on there. You'll need maybe some underlying things to install that with it. It'll make sure, say Python, it'll make sure that Python's installed before it tries to install the package, and go through and make sure what all it is. That's dependencies. So knowing how to install it, there's usually an installer depending on which version of Linux operating system you have. It'll be something called Yum is what happens on CentOS type machines. On Ubuntu machines, there'll be something called apt-get, where you'll do an apt-get install. So, and these packages live in something called repositories. Those are typically out on the internet. A lot of times, for most software, for most installations, those repositories are already set. But if you're going to do some third party or some other type of repository software you need, you might have to find the repositories. That's usually tells you in the software where the repositories live. And there's again, depending on which version of Linux you're dealing with, you'll have to go and do some commands to install those repositories. And say, for example, CentOS, that would be like a Yum update. Once you have repositories in there, you do a Yum update that'll allow your OS to know that, okay, there's a whole other thing out there to make sure that, to look for if I'm looking for a thing. So when I type in Yum install something, it knows where to go find that something and all the dependencies and all the various pieces of software needed. Third-party repositories can be a possible threat since they're not really sanctioned. What they'll typically do with third-party repositories, they'll have some sort of signature for them that allow you to go out and verify it. So you'll download the signature, you download the software, you run the signature, and then you verify that signature on your machine, or it'll verify it as part of the repository, part of the installation. Packages, dependencies, and repositories work in the OS. They're all like executables, and maybe configuration files, and maybe library type files, and they all just get called and get plugged into the OS. Package management, how to install repos. Well, repos are typically you download something. Actually, you typically don't. You typically download a location, an HTTP or URL, and you'll say when they, and you'll say here they are. You'll install it in the next section here. Approved repos and CentOS. That's usually something called yum.repos.d/etc. There's a file, a directory down there. It'll have tons of this stuff down there. And it'll all the list of stuff. And part of the install is that you introduce it. Okay, I put that directory there, that URL there, and where it lives and whatnot. There's like repo configurations, and you can find them usually. And CentOS are usually in with a dart repo. Silent press, shows. What are you going to do here? Wiki. Select one additional. Yeah, select one of the additional CentOS. CentOS is usually one. CentOS is like a fork. Used to be a fork of Red Hat, RHEL, Red Hat Enterprise Linux, and they kind of broke apart. So one of the main ones you use is there's one that's called the Enterprise Repository that you'll put on there. That'll allow you to get all the same software that you would install onto a Linux, onto Red Hat to make it look more like Red Hat. All right. Moving on to section 2 here. RAID dynamic disks. Now that can't be what they look like right there. That's a little ancient, and you'll never ever see a disk drive with the platter explodes like that. But I think when back in 15 years ago at Disney, we had something look like that. Each one of those was like a massive, 500 gig or so, 500 meg, excuse me, and they all had to plug them in and out. And where they were located is what's important. So ancient times, we had to destroy them one day, and we're getting rid of them, and they made them make sure that there was HR data on there. You need to get rid of them. So we spent an afternoon with a sledgehammer just throwing them on the ground and smashing them to pieces and throwing them in a dumpster. Okay, RAID. RAID is an acronym that comes from actually a PhD thesis dissertation by some guy who eventually ended up working for IBM. It stands for a redundant arrays of inexpensive disks. That's what he wrote on there. And that was the days when they were first coming out, like Western Digital was starting to mechanize and automate the production of disk drives, and they're grinding them up by the thousands. Well, one of the downfalls of that is that they weren't really, while they're real cheap, they weren't real reliable. And so you couldn't really bet your company on this one cheap disk drive and have all the data on there. So RAID is a way of taking several of those drives, uh, 4 or 5 or 10 or whatever, uh, and putting software on top of it that watches them. Basically, what it is, it's you'll have, like, say you have 5 disk drives. 4 of them will be what's called data drive. The fifth one will be what they call a check drive or something along those lines, depending on the vendor. And what it'll then do is look through each block on those drives and it'll conduct a checksum, basically, and it'll store that checksum on the fifth disk. The idea is that if one of those drift drives go bad, you can reconstruct the missing drive from the other 3 that survived and that RAID block and the RAID thing. And it's a mathematical. That's what the guy's thesis was about. It's the mathematics and how you get around that. RAIDs typically have defined an acronym, how they work. Again, it's a way of using multiple times, knowing which to use the correct RAID type and type. Why? RAID, they break down into numbers. There's like RAID 1, RAID 2, RAID 3, RAID 4, RAID 5. RAID 5 is typically what's used. RAID 5 will tell you that I'll have 4 disk drives, and then plus 1 additional drive that's just for the checksum. Downside is I can only store of those 5 drives. Say they're all 1 gig. I can really only should give you like 5 gig of data. If you run with a RAID like that with 4 of them in one check disk, you lose that one check disk. So you really only store 4 gig worth of data on 5 gigs worth of disk. So you give up some storage capacity in order for this extra drive to provide some security for you. RAID 6, what RAID 6 does, RAID 6 is another one. It basically boils down to you have 2 check drives. That in case the one check drive goes bad, you can jump right to the second check drive, and you burn another check drive, you burn some more potential storage capacity, but it will also increase your reliability of the system. There's other ones too. There's people that'll do like RAID 6.1 and 6.0 and 6. What those are I'll make complete copies. So instead of having 5 disk drives or 6 disk drives in this case, I'll have 12, and they'll just be mirrored copies of each other. That way I can lose the whole RAID box and still keep running. That's kind of a belt and suspenders approach. Someone password overview. Yeah, here's just going through a RAID costs. Linux RAID. Windows dynamic disks. Windows dynamic disks, those are a way of, you can create a disk drive that really, or what appears to be a disk drive, a file system that can span multiple disks. It allows you to do things like, if I'm starting running out of space in this drive, I can add another drive and grow it off into additional drives and kind of combine them together, which is, kind of a nice thing to do. That way, otherwise what you'd have to do is you have to buy a bigger disk drive, dump the original drive to some tape or somewhere else, and then copy it back into the bigger drive, causing outages for everybody. These dynamic drives, you can grow them on the fly while everybody's still using them. We do a lesson, different types of RAIDs. Yeah, again, go through that lesson. That's a good exercise for you guys. Nowadays, what will happen is a lot of stuff stored out in the cloud now, and they have something similar to RAIDs, but they're like exist of many more disk drives and much larger and spread out over many, many more machines and whatnot. So instead of getting a RAID is also typically a machine that you buy. You buy this one piece of hardware, you put as many disk drives as you can in there, and everything's contained in that hardware. Where you get into more distributed type storage systems that not only they have more hardware, but you'll spread it out over multiple machines. So instead of just having a box with a bunch of disk drives, I have a room with a bunch of machines, all of which have disk drives, and the software kind of takes care of all that stuff. What does RAID 0 protect against? Nothing. RAID 0 is kind of like having just a disk drive by itself, which is used RAID 1. RAID 1 is typically just a mirrored copy, so I have exact complete copy of it. When you should use RAID 0 versus a RAID 1, well, use a RAID 1 if I want to make sure if I lose one of them, I still got a copy of it. RAID 0 is good for things like temporary data. I don't care if I lose it, if it goes bad, so what? I throw it out, put a brand new fresh one in there, rerun my jobs, and it's just storing temp type stuff. All right, users, groups, and CentOS. Users and groups. To a Linux box, your user ID is not really a name, it's a number. So every user ID will have a number assigned to it, and the system typically assigns it. And there's usually like a number 1 or a number 0, which tends to be the root operator, root user of the machine. There's also permissions. And Linux boxes are groups. Groups are the same way. Groups are groups of users, as they would say. So if I have a whole group of users and I want to assign these permissions and have them all get similar characteristics, I'll just put the permissions to the group and it'll assign individual users to that group. How to change ownership? There's a command out there, and CentOS is called chown, CHOWN, change ownership. It also allows you to change permissions. Standard permissions on a Linux box is there'll be 3 groups of permissions. There'll be read, write, and execute type permissions, and the 3 levels of that will be for the owner itself. So the owner typically has read, write, execute. Actually, usually has read, write. Execute means now I can actually run that thing as a program. So it'll happen a lot of people will write scripts and they want to execute them and say, no, it'll give you some strange message. That's because they forgot to put the execute permission on that thing. There's the next level of permissions would be for groups. So I can put a level of permissions for groups, and the third one would be for the world. So everybody in the world, users, standard users, even guest users can log on. If there's read permission on a particular file, then people with pretty much not even an ID, just are using it as a guest, can go and read stuff, which is useful a lot. If you have a machine that you're using that say as a kiosk out there, you just go ahead and set that. The downside is that there is no security on it, so it better be public information and whatnot. How to create users and groups? Again, there's a command for that. Create user, and I think it's create group, depending on which OS you're on. And you assign users a group. That's just you just add them. There's another command. You just say take this user ID or name, and then go ahead and add them to that group. A bunch of videos, exploring groups. Again, the best way to look at users, groups, and permissions. I usually use it on the command line. There's an ls command. One of the arguments on it is ls-a for all. And actually, some of them you can do an L for all and long, and there'll be a thing. So, let me show you one here. An A. Am I right? I'm in my home directory doing ls-al. That's all these things here. These are your permissions. So I'm going to dot. This actually refers to itself. Dot refers to the directory above it. You look at these guys here. That first character is the directory. That's telling you that that's actually a directory. And this RWX means I had read, write, and execute permissions for just the owner. Now let's take something here. Let me do TouchWorks. See there? So now the group has read and the world has read. I have read and write. They're these can be referred to as numbers. Actually, they're octal numbers. So one of the things you'll see a lot is say change mod, which is change the mode of it. 777, things turn everything on. We'll write test. Look at it again. And now you'll see everybody's got read, write. The owner's got read, write, execute. The group has read, write, execute. And the world has read, write, execute. Why you would do that? I mean, there's lots of reasons you might do that, but sometimes you have some kind of permissions problems and you don't know exactly what's wrong. I'll just say, boom, just smack it. Almost like hitting it with a hammer. Just turn off all permissions and let anybody do whatever they want. See if that helps. Add user, here you go. Command password. Password is obviously the command that sets your password or changes it. Group add. Make dirs, making directories. Changing groups, change what group you're in. Here's ls-l. There you go. Kind of what I just went through. Change mod is for changing permissions. 777, like you get here. You can also, there's some ways of doing it with actual numbers or letters. I think what I'll do a lot if I want to make something just executable, you can do a change mod u plus x. It'll go ahead and a file name. It'll just give the user execute permissions. Here you go. Yum install, that's your command for installing packages. Deliverable do, here we go. Research and install another Linux. There's lots of them out there. Uh, One of the ones I like to use a lot is there's one out there called Fedora. It's like the major branch of, I guess it's the System V version of Linux. It's also what CentOS and Red Hat are based on. Just how to search for it, download them. You just find the name of it. Fedora is one, or Debian's another one. There's tons of them out there, and just go ahead play with it. Again, VMs are nice. That way, if you screw it up, you just delete it, start another one. Same with this. I'm going to put this test OS on there. When you see a lot of something called Kali Linux, it's not really a new operating system. It's a version of an Linux operating system that has a bunch of security type packages pre-installed in it. There's this write up questions. The speed of boot up, how to perform, right? These are things you might want to use. Typically, when I pick an operating system, it's because I'm planning on installing some application, and that application works best on a given operating system. That tends to be what drives most of my slish or decisions. Or it can be like Windows or Windows versus Linux. It can be more of a religious thing in some branches. Researching. How would you research an operating system? Yeah, and on and on. Can do all kinds of stuff. Uh, Typically, you just go in there and play with it. You play with the man pages, look for different commands, and just do some, trying them out. Do some reading and Google it even. Pull down the manuals. You find that these manuals will be quite voluminous. They'll tell you everything you really need to know, but usually in so much detail, more detail than you typically need. Mac OS High Sierra, Windows Server. So we already have some of these. And Fedora, that's what I mentioned. You may download, install. Again, just Google Fedora download, and you'll get that. New submission. Again, it should all be got this far. It's pretty familiar for you guys. And this one. Notice on this guy, this is 30% weight, so this is a big one. Try to do a little better job. I don't not a better. Just do your typical job if you're doing. Most of them have been okay. But remember, don't forget this one. This can make or break your grade. And technically, it's 2 sections, right? 2 videos to be graded. Average or both, right? First section, explain what is a package. They went to packages. That's pretty much what we did. The second session is right here, virtual machine. So do it 2 separate videos. Do this one, which is more like week 4. This one is more of like a review of the entire course. And again, here we go. Explain what a package is, what is a repository. Again, go through all these things, make sure to do 7 and 12. Reason we do that because that way, otherwise, if they're bigger than that, you'll have trouble uploading them to FSO. Or so. Again, you can always, if they're too big and you can't get them compressed, you can go ahead and go on to YouTube. If you have an account on YouTube, you can set it up and make it a verified account, which pretty much means they just send you an email and you got to respond. So it has your email, and then it should let you upload up to actually over 15 minutes. And that's it, week 4. Again, sorry for this, a little abbreviated. I'm going to stop the recording and go ahead and turn it into an MP4 and upload it, put a link to it, upload it to my YouTube and put a link on it. Take it easy and goodbye.